All right, so in this video, we're going to look at one of the indeterminate forms when we have 0 times infinity. All right, so here I'm trying to figure out this limit. And if I try to plug in 0, I'm going to get 0 times natural log of 0. And the natural log of 0, it's actually an asymptote that is negative infinity. So I have 0 times infinity. That's one of our indeterminate forms, so we have to be able to use L'Hopital's rule in order to figure it out. All right, but L'Hopital's rule only works when I have a fraction, that's 0 over 0 or infinity over infinity. So there's this weird thing we're going to do that we're going to turn this non-fraction thing into a fraction. All right, now I'm going to write what it is first and then kind of explain how we got there. All right, so there's a bunch of different ways you can see how we got from the left to the right. All right, the first way is just kind of looking at fractions. If I have x over 1, if I move this to the bottom and make it 1 over x, that's going to be the same thing because dividing by 1 over x is the same as multiplying by x, just like it's our reciprocals. 2 is the same thing as 1 over 1/2. All right, so that's one way you could see it. The other way you could see it is this is x to the first. I can use my negative exponent rules to turn this into 1 over x to the negative 1. All right, those are the same thing. I just moved it to the bottom and made it a negative exponent. But x to the negative 1 is the same as 1 over x. All right, so a few different ways you can see this, but this thing that I wrote is the same as our original problem. All right, but now if we look at our equation, if we try to plug in 0, now the top is still going to give me infinity. All right, natural log of 0 is negative infinity. But on the bottom, I have 1 over 0. 1 over 0 gives me really big numbers. That's also infinity. So now that I have that written out, I have infinity over infinity. And now with this newly written form, I can use L'Hopital's rule. L'Hopital's rule says I take the derivative of the top is 1 over x. I divide that by the derivative of the bottom is negative 1 over x squared. And I'm going to do a little bit of simplifying. I'll write it here. All right, dividing by a fraction is the same thing as multiplying by its reciprocal. And that x squared and that x are going to cancel out, so just give me negative x. And now I can plug in 0 and just get 0. So my final answer is just 0. All right, so this is the key when you have an infinity times 0 situation. We're going to take the simpler of the expressions and put it on the bottom of this fraction. All right, so we kind of make this fraction out of nowhere so that then we can use L'Hopital's rule. All right, so let's do it one more time. This one is a limit at infinity. So if I plug in infinity, I get infinity sine 1 over infinity. 1 over infinity, 1 divided by infinity is 0. And sine of 0 is 0. So again, I get infinity times 0. So we have an indeterminate form. We'll have to use L'Hopital's rule. All right, whenever we have the 0 times infinity, I'm going to take the simpler of the expressions and throw it on the bottom of this fraction. So I can't just move it to the bottom like this because that wouldn't be the same expression. What I can do is do 1 over x on the bottom. Now if I try to plug in infinity, the top's still going to be 0. The bottom 1 over infinity is 0. So now I get 0 over 0, and I can use L'Hopital's rule. All right, so L'Hopital's rule, same limit. The top, I'm going to have to do the chain rule. So sine turns into cosine, but the inside stays the same. And I multiply that by the derivative of the inside is negative 1 over x squared. On the bottom, I take the derivative of 1 over x, which I just did, is negative 1 over x squared. All right, you can see, because this is multiplication, I can cancel these things out. This is the same as the limit as x approaches infinity of cosine of 1 over x. All right, once I've done L'Hopital's rule and I've simplified a bit, now I try to plug in infinity again. If I plug in infinity, I get cosine of 1 over infinity. 1 over infinity is 0, so this is cosine of 0, and that is 1. So my final answer is 1. All right, so the horizontal asymptote of this expression is 1. All right, so this is how you do 0 times infinity indeterminate forms. You're going to turn the simpler of your equations, and you're going to put it in the bottom of this fraction as a fraction. So you're kind of making two fractions at once, this big fraction so you can use L'Hopital's rule, and a second fraction to make sure that this expression is actually equal to that expression. Once you do that, just do L'Hopital's rule just like we did previously. Take the derivative of the top and the derivative of the bottom. And these ones you have to do a little bit more simplifying because you made the problem pretty complicated by putting this fraction on the bottom. But do any simplifying you can, and then try your limit again. All right, so that's our first extra way that we can use L'Hopital's rule.